Hello, everybody. Here we are, 1.6, exploring the Pythagorean theorem. So our objective students will use the Pythagorean theorem to identify right triangles. So as you recall, the Pythagorean theorem proves that a squared plus b squared equals c squared. But this is only true, okay, only true for right triangles. So you can use this to prove that you have a right triangle. And if this is not true, then our triangle is not a right triangle. So we can use it to kind of prove in reverse as well. So let's start with a couple of definitions. An acute triangle, not just an adorable triangle. It's a triangle that has all three angles less than 90 degrees. So we have a triangle like this. The degrees inside a triangle always add up to 180 degrees. And it could mean that this angle here is, 60, and this is 40, and this is 80. So all of them are less than 90 degrees, and that would be an acute triangle. An obtuse triangle has one angle that's above, or let's say greater than 90 degrees. Okay, so it might have a kind of open angle like this and connected there. So again, it's got to add up to 180. This could be, say, 110 degrees, and this could be, 40. That brings us to 150. So this one would have to be 30 over here. So that would be an obtuse triangle because it has this big angle that's above 90 degrees. You can't have more than one angle that's greater than 90 degrees because then you wouldn't have enough to add up to 180. So it's only going to be one angle that's greater than 90 degrees. And the right triangle, I think, as we know, has one 90-degree angle. So classic triangle like this, it always typically has that little square in the corner to show that that's 90 degrees. And the other, angles could be 45 and 45, for example. Okay, so the Pythagorean theorem only true for right triangles, not true for an obtuse triangle, not true for an acute triangle. And we can use this fact to prove whether or not a triangle is a right triangle. So how can you tell if the triangle is acute, obtuse, or right when the angle is really close to 90 degrees? We can use the Pythagorean theorem. So use the Pythagorean theorem. Okay. So let's look at three triangles and the area formed by the squares on each of their sides. From the diagram above, okay, well, let's not read that sentence just yet. So here we have side lengths 6, 8, and 9. The square of 6 is 36. The square of 8 is 64. And the square of 9 is 81. So I know that 36 plus 64 does not equal 81. So I know that that's not a right triangle. And you can tell by looking at it that it looks like it has angles that are less than 90 degrees. Here's another one. We got this area is 36. This is 64. That's 100. I do know that 36 plus 64 equals 100. I know that to be true. So this is, I think, obviously going to be our right triangle. This is going to be acute. And our last one, we have 36 again plus 64. That does not equal 121. And you can tell we got this big angle right there. It looks like bigger than 90 degrees. So this is going to be our obtuse triangle. So from the diagram, it's obvious that the one on the left is acute, the middle is right, and the left is obtuse. So now we can use the Pythagorean theorem to find out if the following triangles are right triangles or not. So let's look. It doesn't have the sides labeled, but what do we know? We know that the hypotenuse is always the longest side. So we've got 8 here, we've got 5 here, and we can put 9 there. But I guess I shouldn't put that little square yet because we don't know if this is the Pythagorean, we don't know if this is a right triangle or not yet. So if it is, then 5 squared plus 8 squared will equal 9 squared. So 25 plus 64 should equal 81. And does that equal 81? Well, doesn't look like it. 25 plus 64 equals 98 or 89, my bad. So let's go 89, 81. And in math, to show that something does not equal, we put a little line through the equal sign. So 89 does not equal 81. Since 89 does not equal 81, then this is not a right triangle. Wow, my writing isn't the best here. Let me write this nicer for you. Maybe I should type it. Not a right triangle. Okay. Let's do the next one. So we got a side that's 3, a side that's 4, and a side that's 7. So does 3 squared plus 4 squared equals 7 squared? Is that true? 3 squared is 9, and 4 squared is 16. Does that equal 7 squared, which is 49? No, this 9 plus 16 is 25, and that does not equal 49. So no, since 25 does not equal 49, then this is not a right triangle. Okay. So again, not a right triangle. And I knew, by the way, remember this is important to know. I knew that this would be our potential hypotenuse because it was the longest. The hypotenuse is always the longest. So I knew I had to set up my equation like that. Let's do another one. So we have side length of 8.25. We have a side length of 11. And we have a side length potential hypotenuse of 13.75. So is it true that 8.25 squared plus 11 squared equals 13.75 squared? So is that true? Let's see. I'm going to do 8.25 squared, 68 and a bit. Oops, 68.06 plus 11 squared is 121. Does that equal, let's see, 13.75 squared, 189. Okay, the ending looks promising, 189.06. So let's see, 68.06 plus 121 equals 189.06. So indeed, those do equal. That is true. So since, I feel so excited, since 189.06 equals 189.06, then this is a right triangle. So since the Pythagorean theorem is true for this triangle, then it is a right triangle. The last bit, and there's some questions about this, is identifying Pythagorean triples. So there's, well, I'll read this. When 3 sides of a triangle meet the requirements for the Pythagorean theory and they are whole numbers, they are called Pythagorean triples. So one of the more common triples is the 3, 4, 5 triple. You see this triangle a lot. One side 3, 4, and 5. That's a classic Pythagorean triple. It's also true that if you times each of these sides by 2, it's still going to work. So if you had 6, 8, 10, still Pythagorean triples, etc., etc. So our first question is the above example, so this example that we just did right here, example C, is the above example, is C Pythagorean triples? You might be tempted to say yes because it worked. It proved that we had a right triangle. However, it's for whole numbers, and we had decimals. So no, because the side lengths were not whole numbers. Okay, so we had, 8.25 and 13.75. So no, even though that was a right triangle, this is not a Pythagorean triple. So let's see which of the following are triples. So they are a triple if 8 squared plus 15 squared is going to equal 18 squared. So let's see if that's true. 8 squared is 64 plus 15 squared is 225. I'm pretty sure I can check. Yep. And does that equal, let's see what 18 squared is, 324. Okay, come on, 324. So let's go 225. I'm adding up our left-hand side here, our 8 squared and our 15 squared. So 15 squared plus 64, what does that equal? 289. And that does not equal 324. So that is not a Pythagorean triple. Next, let's try this one. Let's try 11 squared plus 60 squared. Does that equal 61 squared? So let's see. You can make a prediction now if you'd like. Let's do 11 squared. I know that to be 121 plus 60 squared, I think is 3,600, right? Yeah. I can do this one in my head. 121 plus 3,600 is going to be 3721. Does that equal 61 squared? So let's see, 61 squared, 3721. So yes, indeed, this is a Pythagorean triple. Okay, thank you so much. I will let you know what textbook questions I'd like you to do.